Hi everyone, my name is Yurii Halias and today I'll represent our research on emotion-aware film recommendation using heterogeneous graph neural networks. This project was conducted at West Ukraine National University together with my colleagues Khrystyna Lipianina-Honcharenko, Myroslav Komar and Mykola Telka. Nowadays, users are overwhelmed with digital content. Traditionally, recommender systems usually rely on ratings and viewing history, but they are ignoring emotions, which are key drivers of user satisfaction. So our goal was to create a system that not only recommend their movies, but also predict the user's emotional response. For example, joy, sadness, or excitement. While there are many studies on emotion recognition from text or video, very few integrate this knowledge into recommender system. Existing approaches focus on rating prediction rather than effective personalization. Our model fills this gap by connecting users, movies, and emotions in one heterogeneous graph. The system consists of several stages: data collection and cleaning from IMDb, TMDb, and emotional datasets, graph construction. We built a network of about 68,000 nodes and 103,000 edges. Feature initialization, movie genres, user demographics, and emotional embeddings from EmoBank, and training using relational graph convolution network with class balanced loss to handle emotional imbalance. Our heterogeneous graph includes three types of nodes: users, movies, and emotions, and four edges types: view, rate, dominated emotion, and preferred emotion. This allows the model to capture not only direct interactions but also contextual emotional relationships. The implementation was done in Python 3.10 using PyTorch and PyTorch geometrics for model training, scikit-learn for metrics, network-X, and matplotlib for visualization. We trained the model for 50 epochs with early stopping based on macro F1 score. And in this experiment, 80% of graph was used for training, 10% for validation, and 10% for testing, providing an independent assessment of models' generalization capability with in the multi-class classification of 8 dominant emotion in user-movie pairs. This table summarizes subsystem metrics on the test set. The proposed GNN achieves an accuracy of 73.8% and macro F1 of 71.3%, accompanied by balance precision and recall scores of 71.9% and 70.7% respectively. The difference between macro and F1 scores indicates moderate class imbalance, which does not lead to significant bias of the model toward frequent emotions. Comparison with two baseline approaches is presented in this table. The GNN demonstrates an accuracy gain of 30.3 percentage points over logistic regression and 19.1 percentage point over random forests. Similarly, the macro F1 increases by 33.1% and 21.4% percentage point respectively. The common classification errors occur between close pairs like excitement and joy, and sadness and disappointment. For rare classes, precision is lower. However, there are still challenges. Rare emotion have f1 less than 0.6. Cold start problem for new users of movies caused a drop of 12 points in accuracy. And scaling beyond 1 million edges significantly increase computational cost. In future work, we plan to explore dynamic GNNs handle temporal change in preferences, multimodal fusion using audio, image, and text features, few shot learning for new videos or users, fairness aware of explainable AI, reducing bias under 3%. So just to summarize, we propose the heterogeneous graph model for emotion-aware movie recommendation. It's significantly improved for both accuracy and personalization. And this approach paves the way emotional intelligent recommender systems capable of understanding not just what user like, but also what they feel. Thank you for your attention.